welcome. Thank you guys for coming out. Why can't they solve word problems? That is the question we are all always asking ourselves in math education. So this talk is really going to be about word problem schemas as an evidence-based approach to mathematical thinking. Key emphasis on that word thinking. Schemas are a really great research and evidence-backed way to get students actually thinking about math in a way that increases their achievement. So I kind of want to start us off with a real quick waterfall. I know folks have probably done this on Zoom before. You're going to type your answer, you're going to wait. And then when I say go, we will send all the answers at the same time and create a nice little waterfall. And I just want to get a quick gauge of, on a scale of 1 to 5, how familiar are you with word problem schemas? So you can just type in your number and then wait for a moment before we all hit send. 1, you've never heard of schemas. 5, I use them successfully with my class, or somewhere in between. If you finish early, you can do the extra credit and let me know some of your initial thoughts on schemas. What have you heard or not heard before? Why did you attend the session? And I will give us about 30 seconds to type that in, and then we'll keep it pushing. A little bit of think time to start off. And then, yeah, you can just let it into the chat. You can go ahead and type in, okay, I'm seeing 1s, 3s, 2s, a good range for folks interested. Christine says, and any help with word problems, I am right there with you. This is the #1 struggle for our students in math. 3, how do they translate to high school, Beth? That is a great question. I've been teaching 5th grade, so I can't promise you I'm going to get into high school today, but I think there is some good translation. There's a lot of work that's been done with middle school and more advanced kind of like ratios and proportions problem that I think could translate. Okay, 4, 3, 2, excited to learn more. Excellent. Cool. All right. Yes, 5th grade is pretty hard math. I know it is. Okay, cool. Well, thank you all for sharing. I appreciate that. It helps me get a good gauge. I hope this session is super useful to you. And if it's not, we're going to have that Q&A at the end so you can ask all your questions. We can tangle about the research, whatever else it may be. Oh, and of course the slides are cutting off. I mean, we're just gonna rock, with it, okay? For years, most of my students, right? I'm teaching 5th grade, especially my multilingual learners, which was a majority of the students that I was teaching in Minnesota, were struggling to cross that bridge between math and language. We're struggling with word problems, and that's what I'm seeing a lot of in the chat is just, how do we get our students any kind of help with word problems? Let me give you a little bit of demographic context just so you understand the context that I've been teaching in for the last number of years at a charter school in St. Paul, Minnesota. I live right across the river in Minneapolis, Minnesota. And as of this last year, about 75% of our students qualified, the families for free and reduced price meals. I think this number, it was used to be like closer to 98%. Minnesota changed how they counted it, so it got a little bit lower. Linguistic barriers are a huge thing for the students at my school, right? They're great kids. They've got a lot of energy, a lot of curiosity, and almost 60% of our students are multilingual learners, many of whom came to the country within the last 1, 2, 4 years and still have a significant language barrier, which obviously shows up with word problems. And when we talk about equity and systemic racism in education, most of our students are from Black immigrant families, Somali, Oromo, about 87%. We've got that 8% white is mostly students at our school who are refugees from Syria, Jordan, and other Arab countries. And then we've got a few students who are recent immigrants from Afghanistan or the Philippines as well. So when I'm thinking about my students and their struggle with word problems, I'm thinking about it in this context of, barriers of economic disadvantage, of linguistic barriers, of institutional racism. And that's what you saw in my classroom data. So let's go back to 2 years ago. 17% of my students were proficient in math on that end of year state test. So the vast majority just did not get there, 17%. And if we compare to 5th graders in the state of Minnesota on that math MCA, that end of year high stakes assessment, students who qualified for free and reduced price lunch overwhelmingly were not proficient. Our English language learners in Minnesota, only 8% passed that test. Our Black students, only 19%. Right? If you look at our Black English language learners, 7% were proficient in math. I mean, these are numbers that to me show that we as a state, including me as a teacher in my classroom, we're failing our students. especially the students who were most looking to school and the families who were most looking for school to provide educational opportunities for their students. They were struggling with that bridge between math and language. And even in this situation, I thought as a teacher, I was doing so many things right. I was looking at the research. I was using direct, explicit, interactive instruction. I had a fact fluency program in place. I was seeing lots of gains in FastBridge, in growth data, but it wasn't showing up on end of year proficiency. And I did a lot of diagnostics. I did some deep dives on my data, and word problems were the number one barrier for my students. So what do? Are we going to use a draw a picture strategy, 3 reads, keyword strategies? Like so many teachers, I've tried so many different things, and none of it worked, right? I mean, keyword strategies do not work. And that's one of the takeaways that I've learned from researchers like Sarah Powell and others is, so often our kids are struggling with word problems. Let's give them a keyword strategy. Let's make an anchor chart. Oh, if you see this word, it might be addition. If you see this word, it might be subtraction, right? But we can even look at a simple problem and see that keywords more often than not are going to lead our students astray, right? Amina has 9 apples. She has 4 more than Mohammed. How many apples does Mohammed have? A keyword strategy might tell students, oh, the word more. We're going to use plus. We're going to use addition. The kid says 9 plus 4, 13. They confidently write their answer and they proceed, right? But of course, that's not the correct answer to this problem. We're trying to compare the amount of apples that Amina has to the amount of apples that Mohammed has. And a keyword strategy doesn't get students thinking, doesn't get them thinking about the structure of the problem, right? If you take an example from the 5th grade MCA test in Minnesota, 6 people evenly divided the cost of a dinner in a restaurant. They paid a total of $156. How much did each person pay? Some students, they might use a keyword strategy and see divide, and they might get on the right track. Some students would see total and go, oh, I remember. My teacher told me total is addition, total is plus, 156 plus 6, and they're going to type in their answer. And they're not thinking about the actual relationships between the quantities in this problem. They're not doing real deep mathematical thinking. And that's what the research suggests, right? This very interesting study from Sarah Powell and her team found that on high stakes tests, those end of year assessments, keyword strategies work less than 50% of the time. They reviewed hundreds of items from different state tests and found that these keyword strategies over and over again, just like those examples I gave, are leading students astray. So I'm not going to spend time ragging on keywords, right? I knew it didn't work. It wasn't working for my students and teaching them how to think. So I was struggling. If keyword strategies don't teach students how to think, and research shows that keyword strategies don't even work, what am I going to do? I've got 17% of kids proficient in 2024, and the years before that were similar, right? It was low proficiency. I thought I was failing my kids, right? The solution, as I'm digging into this research, I hear in the Science of Math Facebook group, in peer-reviewed research I'm looking at over and over again, schemas. So instead of keyword strategies, what are we going to do? We're going to teach types of word problems. And what I think is essential with schemas is when we say types, we're not grouping them by keyword and we're not grouping them by operation. Schemas is not where you as a teacher say, this week we're doing addition word problems. No. This week we're doing multiplication word problems. No. We are not saying that the type is the operation. Instead, we're looking at the underlying mathematical structure of the problem. We're looking at the actual relationships between the quantities. And here's what that could look like. The first schema that I teach my students in 5th grade, where I was able to get them from 17% proficiency to something much higher, is the total schema. It's additive, so you're going to add or subtract. Part 1 plus part 2 equals a total. You're going to teach this to students. It's very simple. When you give this introduction and repeat it over and over again, they can internalize it. Even, our multilingual learners, our kids struggling with language abilities, if you get that repetition, they will learn very quickly. Part 1 plus part 2 equals total. Maybe a problem is part 1 plus part 2 plus part 3 equals total. You teach them the word total. You teach them maybe this equation, and they can use it to get these problems that with a keyword strategy are virtually impossible, right? For a school festival, teachers gave out 872 ride tickets. If 728 of the ride tickets were given to children, how many tickets were given to adults? This is a word problem from the Minnesota Comprehensive Assessment end of year test. Okay, the keywords are not really giving our kids a way to look at this. But with schemas, you can teach your students the structure. And a way to get that to be really tangible and practical for students rather than using words like quantity, instruction, relationship is we just give them a graphic organizer. We have them understand it and memorize it and use it over and over again. And with that repetition, an organizer that, you look at total, you look at part, you look at part, it's confusing for a lot of students at first. With constant repetition, they get this down quick. And all of your students can be really, really fluent with using this. So they can start to understand, okay, I see a problem where there's tickets, and there's two kinds of tickets. There's children's tickets and there is adult tickets. So the two kinds of tickets can be the two parts, and all the tickets are the total. So the students can learn, okay, I'm going to slot in 872 tickets is my total. 728 of these tickets were given to children. So I know, oh, I'm going to take my top total minus my bottom part and get how many tickets there are for children, right? You don't teach this to kids in 2 or 3 or 5 minutes like I just did. It takes a lot more repetition. But when you give them that repetition and that fluency practice, they really get this, right? I'm not going to go in depth into every schema, but just to give you an overview of the 5 basic schema that we would teach at the elementary level, by the end of 5th grade, you would have the difference schema. You can start teaching this in lower and middle elementary. Greater minus lesser equals difference. So these are for problems where we're comparing two quantities. We had that example. Amina has 9 apples. She has 4 more than Mohammed. How many apples does Mohammed have? The student, instead of relying on an ineffective keyword strategy, can look at this problem and go, wait a minute, I am comparing. Amina has this many apples. Mohammed has this many. Okay. If Amina has more than Mohammed, what does that look like? And they have a second graphic organizer that they memorize. Their greater is taller. This is very intuitive for students. The lesser is shorter. And that gap between the greater and the lesser, that is your difference right there. Okay, so students can realize if Amina has more, that's the greater amount. She's got 4 more than Mohammed, that's going to be a difference. So 9 minus 4, oh, Mohammed's got 5 apples. Way more effective than a keyword strategy. The last additive schema they're going to solve with addition or subtraction is a change problem. So you're going to teach students that we have a start amount that increases or decreases to a new amount. So your start, you either add or subtract some amount of change, and it gets you to the end. So as an example, Kaylin had $398.40 in her bank account. She took out $38.75 to buy some sneakers. How much money was left in her bank account? The students can draw this graphic organizer that shows their start amount. Your arrow shows that it's going to be a change, either increasing or decreasing to that new amount, which is the end. And students can actually think through the quantities in this problem to know, okay, she had this much at the start. I know it's the start because she took out some money after that. And remember, after is a time word. I see my arrow is showing change over time. I know that took out is going to be minus, right? And even your multilingual learners who've been in the country a year or two, with enough repetition, they can start to learn, okay, took out, that's going to be subtraction in this type of problem, okay? And they can figure out what we have at the end. So the additive schemas are total, difference, change, and students are solving them with addition or subtraction. Your multiplicative schemas, there's only 2, right? And these obviously we're not teaching to 2nd grade, right? Once you get into middle and upper elementary, you can add in equal groups and set problems, also called comparison. That's where students are solving the word problems with multiplication or division. And it could be either one for either of these schema. So here's an example with equal groups. You have groups with an equal number in each group, and that equals your product. So example, 6 people evenly divided the cost of dinner in a restaurant. They paid a total of $156. How much did each person pay? So the students, once they're familiar with equal groups, they realize, wait a minute, I do have groups with an equal number in each group. My groups are my people. And what is in the people? Well, there's money in their hands that they're going to pay. Right? I often, when I'm teaching equal groups, I use the idea of in each group. It's in a container or it's in someone's hand, right? You can use that kind of language with kids. And they've got another graphic organizer for equal groups. Again, when you throw it all out in 5 or 10 minutes, it seems overwhelming. But if you teach this over a number of weeks, one piece at a time, students internalize this really well. you can get to 100% of students being able to draw and use this graphic organizer with at least some fluency in a week or two, right? And once they do that, that's where the real thinking starts. And they got to do the hard part. This is the part they struggle with of figuring out where do these numbers go? Okay, 156 is my total. That's going to be my product. 6 people is my groups. And then I can say, okay, product, I'm going from right to left. So 156 divided by 6 will give me my number in each group or my amount of money that each person is paying, and they can do that math. Lastly, you have your multiplicative schema. Set times the number of times it's being compared equals a product. So these problems are just where students are comparing, but they're using multiplication or division to compare. Example, Haroon has 72 pencils. Haroon has 8 times as many pencils as Marcus. How many pencils does Marcus have? Students draw the same graphic organizer as equal groups. They just have different labels for it. So that's all you got to teach them when you get to this last schema. And this is the one I teach last because it's the least common, at least in 5th grade. And they figure out, okay, the product is whoever has more. Haroon has 72 pencils. Does he have more or less than Marcus? Well, he has 8 times as many, so that's more. 72 pencils will be my product. 8 times, it's right there in the problem, 8 times. So I can do 72 divided by 8 since I'm going right to left, backwards, you might tell the students, right? They're going to get to 9 pencils. So this is a cool story. I was reading all this research or these articles at least describing how this strategy worked, but does it actually work with students? Well, Sarah Powell, Lynn Fuchs, other researchers have done a lot of work with this. They've studied it with 1st graders, found great results. They've studied it with 2nd graders. They've found great results. They've studied it with students who are experiencing, who are in 3rd grade. They've gotten great results. With students who are experiencing mathematics difficulties at various grade levels, especially elementary, and they've shown the efficacy of this compared to, simple strategies like just draw a picture or use a keyword. They've done work with middle school students showing that it works. They've done work specifically with students who are identified with disabilities, including emotional and behavioral disorders. And again, they found that schema instruction works. They've done this work, this was especially relevant for my context, with emergent bilingual students. So when we talk about our English language learners, our multilingual learners who are struggling to access the language of the problem, even if they might understand the math, the numbers, this is a strategy that has been shown in research to work for those students. But of course, I was still left with the question, would schema instruction work for my students, right? There's always the challenge of you see this in a peer-reviewed study, but is it going to work for me? Is it going to work in my classroom, right? Like, I don't know what kids they had in those studies, but have you seen my kids on a Monday morning? So I had to go in and see if it would work. And that's really what I wanted to focus this presentation on. There's so much great work from Sarah Powell and others where they talk you through the 5 schema types, and there's a few more you can add in middle school. They have a lot of great examples. I have some resources on that at the end of these slides. So if that's something you're looking for more on, there's really, really great resources already out there. But I kind of wanted to spend the rest of this presentation just sharing some ideas just from my experience of how I made this work in one specific classroom. So, we can go and start with that data. 2024, where only 17% of my students were proficient in math. And I thought I was doing so many things right. Explicit instruction, retrieval practice, all of these things. And it didn't seem to be working at the proficiency level. Okay. The only change substantially that I made to my math instruction the next year was adding schemas. Everything else I kept the same. I used mini whiteboards. I did fluency building practice for math facts. I did all these things the same in 2022, 23, 24. The only change I made in 2025 with students facing so many barriers was to add schema instruction. And the results were surprising to me. 54.5% of my students were proficient. Okay, so obviously we're not at 80, 90, 100%. I would love to get there, but it's a huge jump. They outperformed other English language learners in the state by like 40 points, right? They outperformed other Black students in Minnesota by an order of, not an order of magnitude, but by, 30, 40% as well. The overall state average in Minnesota for 5th grade that year was 42%. So they outperformed all kids, period. They outperformed the white kids. They outperformed every racial and economic group. Any way you can slice or dice the data, these kids did better, right? They worked hard for it, but the only change that I made in my instruction was adding schemas, right? And when I looked at the data for the rest of the state of Minnesota and the data for other schools in my classroom, I couldn't find any explanation for it, for this huge jump, other than schemas. And this year, I mean, the students did even better, right? When I was able to deepen my, approach with schemas and really just try and teach it even better. Okay. So, when we look at these routine problems, yeah, on standardized tests, students are able to do way, way better with them. You also are going to teach with schema instruction. You're going to teach those directive word problems, right? That don't fall into a specific schema. And that's part of what I'll talk about as we go through some of the ways that, I was able to try and make this work with my kids. The first strategy is just introducing the schemas with an eye towards cognitive science. So the first thing that I do, and this is just drawn from Sarah Powell and her work with UT Math Spiral and Catherine Berry as well. For each schema, students ask a defining question and they've got a gesture. They've got something they do with their hands while they ask the question, which is just a great little mind-body strategy that helps them build that memory. You also want to teach an attack strategy. RUN, run, is a great attack strategy. There's other ones in the literature. They all seem to work. Pick one that works for you and for your students, right? But for me, it's as simple as I throw up this slide. I tell students, read the question and do the gesture. Our parts put together for a total. Our parts put together for a total. I take it away. I have them memorize it. Turn to your partner. Memorize the question, right? In those first couple minutes, we're not even looking to understand necessarily what does the question mean. Especially for my kids who are newer to English, I just want them to understand how to say the words, how to say the question, how to do the gesture, so we can take that off their cognitive plate, reduce that cognitive load, and then we can get into, okay, what does it actually mean when we say our parts put together for a total? The second thing we're going to do is we're going to teach them this graphic organizer. Every schema has a graphic organizer that maps to the actual relationships between the quantities. Okay. And we're going to do this with a lens towards that instructional hierarchy that Holly mentioned in her opening keynote. Okay. We're going to have students acquire the graphic organizer and acquire an understanding of how it works. And then we're going to build towards fluency and generalization. So we're going to use mini whiteboards. The S got cut off. We're going to use mini whiteboards. That's what I did in my class. There's different ways. Obviously, you figure out what works in your context. But for me, it was as simple as saying, hey, in total problems, we put parts together for a total. Copy this down. You see your two parts on the bottom. You see your total at the top. I want everyone to copy it down. Okay, copy it down in 20, 19, 18. Get the kids going. Make it a little bit of a game to see who can get it written down the fastest. Everyone show me your whiteboards in 3. Show me your whiteboards in 2. Show me your whiteboards in 1. That looks great. That looks great. Ooh, that looks amazing. I love how neat your handwriting is. Oh, Amina, you forgot to write part in your lower left corner. Can you write part? Put art. Okay, cool. Amina, you've got it. Give them that feedback. And then I hit fifth graders with a thing they hate to hear, but it's so good for them. Erase it in 3, erase it in 2, erase it in 1. Now draw it again. Draw it again. Draw it in 20, 19, 18. They draw it again. They get it up there. We give them the feedback. And I'm going to keep doing this until every single student can draw this graphic organizer from memory. Okay. So we're getting them like fluency in literally drawing the organizer. And it doesn't take that long. Maybe 10 minutes on Monday, 10 minutes on Tuesday. And then most of the kids are there. But it saves us so much hassle later on. Okay. They make this graphic organizer over and over again. And then we start with really simple examples to show them the actual meaning of the organizer and the relationships between quantities, right? I have 3 markers. 2 of the markers are black and 1 of the markers was red. And we get students to be able to fill this in and understand what it means, right? Maybe you can call students to the front. Okay, I want 2 girls. I want you and you, 2 boys. Okay, you and you coming up, stand up here. Draw what you see as these students are standing here in front of you. This is absurdly simple, maybe for 5th grade, but we start with a couple of these really simple examples because it gives all students access. And the goal is to, as quickly as possible, get to the grade level math. But I think it helps to start with some really simple stuff to build that understanding of the schema. And we're always going back and doing that retrieval practice with the question, the gestures, the graphic organizers, right? All right, everyone tell me the question in 3, 2, all. They can all recite it. We can get choral response going. It's a great strategy to help them memorize it. And as students memorize the questions and gestures, they've got 5 questions and 5 gestures, at least in 5th grade, where we're working with those 5 schema. Then they can apply them to new problems. So I teach my students, okay, when you use schemas, you see a problem, oh, it's not a directive word problem, it's routine. I'm going to ask, are parts put together for a total? If yes, it's a, and I ask the students, tell me in three, two, all, it's a total problem. They know. I say, what if the answer is no? Everyone raise your hands, raise them in three, raise them in two, raise them in one. Okay, Ibrahim, he's going to know as we repeat this over and over, he's going to know, oh, if the answer to this question is no, it's one of the other four schemas. And we build that understanding through constant repetition. Okay, if the answer is no, what is the next question you ask? Everyone tell me in three, two, all. They can get a choral response. Are we comparing two amounts to find the difference? Are we comparing a greater and a lesser? If the answer is yes, it's all, it's a difference problem. If the answer is no, what does that mean? All hands up in three, hands up in two, hands up in one. Yes, you. Yes, it means it's one of the other three schemas. And you basically are building what I think of as like a flow chart, an anchor chart, a mental scaffold, but it's living in the student's brain. It doesn't have to stay on an anchor chart or a slide forever. The students are internalizing this because you're repeating it over and over again. And I will share these slides at the end. So if you want to make a copy of them, adapt them for your context, I hope this can get you started, because these are just some of the things when I was working initially with schemas in my class, was just some of the resources that existed maybe were incomplete, or they were part of a really specific intervention that I wasn't able to do in my class. So having to create these resources took a little bit of time. So my hope is if you can just download, copy, make whatever edits you need, it can save you some of that time, right? And of course, we have to have explicit modeling so students are understanding, okay, it's not just a graphic organizer I draw on paper. It's not just a gesture I do. What does it actually mean? If Khadija bought 0 and 51 hundredths kilograms of apples and 0 and 3/10 kilograms of oranges, how much fruit did she buy in all? We're going to have students practice identifying which of these schemas is it. They're going to debate it. We're going to share with the class. We might do some writing, write with evidence and justify why you think it's this schema. Okay, you think it's change. You think it's total. Let's debate it, right? I think the best one for this might be total, right? And there's some problems students will teach you. I mean, they taught me, I said, oh, maybe this is a total or maybe this is change. And they'll have a good argument for why maybe it's a different one of the additive schemas. That's fine. As long as they can justify their reasoning, I think it leads to some beautiful student discourse, okay? So you get them understanding by doing explicit modeling of these problems. For me, I'm just up on the smartboard. I'm modeling the problem. We're using choral response. We're using all hands up cold calling. We're having turn-in talks. We're getting the students engaged, but really having them with the teacher initially, right? So, the second strategy that you really want to focus on, or at least that I did, is ongoing practice and gradual release. So once students have acquired an understanding of the total schema, we can start to practice with it. And then maybe a couple weeks later, they've acquired an understanding of the difference schema. And then we can start looping that in as well. So, we're going to start with a gradual release of responsibility, teacher-led. You're going to model, you're going to elicit student thinking and give real-time feedback. And this is really, I think, all about managing that cognitive load, making sure students have a basic understanding of each individual schema before they take more ownership. But of course, you want to get them to more ownership. So we're gradually shifting responsibility. I'm doing less and less talking at the board. It's more student discourse, student debates about what schema it is, right? Partners working on problems, or, and this is very important, of course, the kids working independently. And really working on fostering that independent thinking. So you can see, eventually we have a simple scaffold, as simple as, hey, I'm going to make sure I ask you what schema it is, so you're doing it, then show your work and answer. And you can see the students are able to independently figure out, okay, the school district's ordering new books for its libraries. Each of the 18 schools gets this many books. How many books did they order in all? They realize it's equal groups. They've got their graphic organizer. They're showing their work. And, we can reinforce whatever else we want with word problems. For me, it's, hey, give your answer as a full sentence. And a lot of the students are able to pick up on that. Okay. Whatever the schema is, they're able to identify what it is. And, sometimes maybe it's partner work. They had a debate, right? Here we had a question about comparing the school track's length to the length of a nature trail near school. And these two boys were sitting and debating vigorously, right? One guy thought it was set/comparison. He was convinced actually this is a difference problem, right? So as we do more and more of that, the students can get more independent. And what worked for me was giving really frequent quizzes to consolidate and assess that skill. And I just gave them on Schoology. What I would do initially for the quizzes is every word problem would be two questions. The first question is, what is the type or what is the schema? The second question then asks for the answer. And of course, making them turn in a sheet showing their work. And eventually, as we get further into the year, we're going to drop this first question to give students practice with knowing they have to identify the schema, even if they're not explicitly asked, right? You fade that scaffold, as you see fit. It's your professional judgment. So that's ongoing practice. That's gradual release. The last piece, which I will include in the resources that we share out, is you can use AI to get fast and feasible problem generation, right? And when I say AI, it's used by you, right? I used AI to generate problems for the kids because my curriculum did not provide enough for them. So used by the teacher, not by the students. This is relatively simple. I was able to make a protocol going back and forth with one of the AI systems. It's a couple pages long that explains what schema instruction is, what the different schema are, the features of the problem types. And now I just have that saved. So anytime I want to generate, I need some word problems, I need equal groups, I need set/comparison, and I need some difference problems. Like those are the three schema we're struggling. I want to mix them up. I want to give a quiz or a worksheet, but my curriculum doesn't have enough. I just take this protocol, I upload it to Claude, ChatGPT, Gemini, whatever you want to use. I upload the protocol because that gives the AI all the information, the background information on schemas, right? I'm going to describe what I want. Hey, please work with me to generate a 6-question quiz on math word problems for fourth graders. And this is where you can use your professional judgment of, what types of numbers? Are we working with multi-digit? Are we working with single digit? Are we working with fractions, right? Are there certain contexts you want? Like, I want problems that relate to what we're studying in science. Or I have some culturally responsive context that's actually going to be really relatable for my students, and I think it'll help them understand the schema more before we broaden to other contexts. Whatever you need in your context, you describe it. You check what the AI is outputting because obviously it can hallucinate, it can lie, it can make mistakes. But I find that when I upload this protocol, I'll share with you, it's usually pretty good outputs. And this output allows you to just get a printable worksheet, or you can get an IMSCC file. You can upload it right to Schoology, right to Canvas. And if you put it on Schoology or Canvas, you've got a quiz already made for you in like a fraction of the time it takes to do by hand. I don't know about you, but I do so many quizzes on Schoology, and making them by hand, it's brutal, right? It takes a lot of time. So, that's really what I would end on. Schemas are not a one-time lesson. It's not something you cover in 30, 40 minutes like I did here. That's not how you're going to do it with kids, right? It's a routine. For me, I introduced maybe one schema a week, right? We do total for a week. They build a little bit of fluency with that. Next week, I'm going to introduce difference problems, right? So through explicit instruction and cumulative practice across schema types, you can build that. And I think the results that my students were able to get, I really attribute it to schema instruction. That was the one change that I made. And if you look at we don't have the results from the rest of the state for 2026. But if I look at 2025, where 54% of my kids were proficient in math, they beat the statewide average. They beat the averages for every comparable demographic group. Right? Our English learners, they need something like schemas that's going to scaffold thinking. They deserve this instructional opportunity. I really believe that, right? It is not acceptable. I think we all agree that 7% of English learners would be proficient in math. I think with schema instruction, we get that number a lot higher. We take students who are facing, economic disadvantage, who are living in situations of poverty, and we give them that mental scaffold where word problems make sense. Right? If we compare statewide in Minnesota, students facing economic disadvantage, English learners, students who are Black, we can start to combine some of those demographics and see the barriers our students are facing. But I think instruction can make a difference. Obviously, it's not the only thing. We've got to have wider societal changes. But as a teacher, the instruction is what I can control.
Andrew, I'm going to just give you your 5-minute warning here.
Thank you. Appreciate it. And you can do it. I know people say with explicit direct instruction, you hear the canard that, it's oppressive, the students are going to hate it. Well, 70% of my kids said math was one of the best parts of the school year. Before I started schema instruction, 39% did. So am I saying I taught schemas that made them like it? No, but clearly I started teaching schemas and they didn't hate math more, right? I asked them, what do I do? What does Mr. Urevig do that most helps your learning? One kid said schemas, right? Keeps trying until it works. To me, that's the repetition over and over, right? And I really want to end on what this student wrote, math, because every day there has to be something to do with math. You might turn into an engineer or a doctor or any other type of job. You will use math. And word problems give students that bridge to actually use it. Achievement gaps are opportunity gaps. So instructional opportunities matter. And I think that direct, explicit, interactive schema instruction can help close the instructional opportunity gap in math. Sorry, I rambled. I was a little wordy, so we don't have as much time for the Q&A, but we will share these slides, I believe. Is that correct, Kata? We'll be able to share with folks. UT Math Spiral, great resource that goes through all the schemas. These are a couple great articles that go in depth on each schema and give examples. Pirate Math Equation Quest is a specific intervention curriculum. There's my email. If you want to talk about schemas, I would love to do it. If you use it in your class and it works, I'd love to hear about your data. I'd love to workshop and just collaborate on that. We can connect on LinkedIn, Twitter, although it's bad for your mental health, so I try to stay off Twitter, but we can connect on there. Yeah, we got 7 minutes or sorry, 3 minutes for Q&A, so not really any time. I apologize for that, but hopefully this.
Thanks so much, Andrew. Another question, how does this go when you start interleaving the problem types? Any strategies that have helped you help kids be more successful at that stage? Like how early do you start interleaving? Like, can you talk a little bit more about that?
Yep. So for me, and this is not based on anything in the research, this is just how I try to apply to my class. I teach total schema for a week or two. Once they're fluent with that, we throw in the different schema. And once they're a little bit fluent with both separately, then we start interleaving the two. So maybe that's 2 or 3 weeks after I first start schema instruction. And yeah, that's the hard part, right? But I think the two strategies that have helped me is one, teaching the basic stuff to fluency, making sure that before we even proceed, kids can draw the graphic organizer from memory and fast. And I mean, at least in fifth grade, they have fun with it, right? Okay, draw it in 15 seconds. Okay, cool. You did it in 15. Let's do it in 10. No, we can't do it. Nope, do it in 10, 9, 8. And they can get fast and fluent with it. So if you do that pre-work, I think it helps a lot. And the other thing is just lots of repetition, lots of practice, and having debate and discussion within limits, right? We're not having 45-minute discussion on which schema it is, but give the students a minute to think, write an answer, debate it amongst each other. And I think that helps them learn to distinguish between the two as well.